Hi, 8th graders. Welcome to video lesson number 2 on waves. Let's review lesson 1 from the last week, starting with waves. They carry energy and transmit it from one place to another. They also can carry information, depending on what type of wave they are. There are two main types of wave. There's a compressional wave, like in this slinky here. If I compress the springs together and release, as you can see, the motion of the wave is back and forth, and the energy starts from my hand and travels down in the same direction. So the thing to remember about this wave is the motion of the wave is in the same direction as the energy being transmitted through the wave, and it's longitudinal, or in a straight line, one direction only. So here's my compressions. As you can see, this spread out area here, they're called rarefactions. When I release the wave, you can see it transmits down through the spring, but the spring itself does not move. So I'm going to illustrate a transverse wave using this long slinky. And the thing about transverse waves is that the energy of the wave goes perpendicularly or at right angles to the motion. So the motion, when I snap it, is going to go that way towards the piano. So the motion is going this way, but the actual energy in the wave is making the wave go up and down. So we've got a right angle, a perpendicular difference between the energy and the motion of the wave. So going back to the compressional wave, the new vocabulary words for today are amplitude, which is the strength of the wave. So I can increase the amplitude of a compressional wave by making the compressions bigger. So here's a small compression, low energy, and then here's a much larger compression, much higher energy. And as you can see, the more compressions there are, the more the strength of the wave. So a compressional wave example would be like a sound wave. So if I compress it more, what I'm doing is I'm increasing the strength or the amplitude of the sound wave, and it's making the sound louder. So now back to the transverse wave. In a transverse wave, the amplitude is also the strength of the wave. And basically, you can have a wave with a low amplitude like this, or one with a much higher amplitude like that. The higher the amplitude, the more energy. So if this was a water wave coming at you from the shore, that would be okay. But if you had a really high amplitude, now you're talking about something that you might be able to surf with and do a much better job and have more fun surfing. Now in the transverse wave, when you increase the amplitude and increase the energy, you get a much higher wave. So here's a low amplitude, low energy. Here's a much higher amplitude with higher energy. And in this type of a transverse wave, the part that's going up at the very top is called a crest. And when the part reaches the bottom like that, it's called a trough. So let's see if we can see a few crests and troughs. Can you see the part that goes up? That's the crest. The part that goes down, that's the trough. Now I wanted to show you a couple of other properties of these transverse waves, starting with the wavelength and the frequency. So right now, if I pretend this is like a giant guitar string and I pluck it, when you pluck the string, you can see it moves around like this and up and down. And this basically is a wave with a frequency of 1. There's only one wave going through it. Now, if I want to change the frequency, I can make a wave like this with a frequency of 2. As you can see, there's 2 waves. And then take a look closely in the middle here. There's a spot. See if I can get this going. There's a spot right in the middle. that's not moving at all. That's a special part of the wave. It's called a node. N-O-D-E, node. You can also turn this wave into one with a higher frequency. So let's see if I can get some more frequencies going here. There we go. More frequencies. You see more crests and you see more troughs. So in science, the amount of waves going by in a given time, especially 1 second, is called the period or the frequency over time. And it's measured in a unit called hertz, H-E-R-Z, hertz. And all waves are described by hertz, how many waves go by in 1 second. So here's a frequency of 1, here's a frequency of 2, there's one of 3, and as you can see, if I spin it faster, I can create a wave with an even higher frequency. So let's review. Wave properties can be described by the strength, which is our amplitude, low amplitude, much greater amplitude, much greater strength or energy of the wave. So if this was a light wave, if I increase the amplitude, basically I'm making it brighter. And then in a sound wave, a compressional wave, if I increase the amount of compressions, like in a sound wave, I am increasing the strength of the wave, or it would be the loudness in a sound wave. And then in a transverse wave, there's a part in the middle that's not moving, and those are called nodes. And then finally, the amount of waves traveling in 1 second is measured in something called hertz. Well, basically, that's my video lesson for today. I hope you learned something. Don't forget to look at the PowerPoint presentation that I loaded today in the Google Classroom, and also there's a video that I put on there with some really cool animations. You just need to watch the first 4 minutes of it. That's all. And then there's 2 questions to answer. And remember, take tomorrow off, take Friday off. So I'm going to give you an extra time. This isn't going to be due until Monday. So you guys take care, and I'll talk to you soon. So now it's time for the video review questions. Question 1. The amplitude of a wave is the strength of the wave. So if you increase the amplitude in a sound wave, what happens? Question 2. If you increase the amplitude in a light wave, what happens? Question 3. In a transverse wave with a frequency of 2, there's a part in the middle that is not moving. What is this called? And question number 4. Frequency of a wave is a measure of how many times the wave passes by a given point every second. What is the name of the unit that we use to measure frequency? That's the end of the 4 questions. Please type your answers onto the worksheet on Google Classroom. And don't forget to wash your hands and stay safe, everyone.